I would start with a design doc that describes the problem I am tackling and discuss in detail the different solutions to the problem. I would share this document with other engineers and stakeholders for feedback and comments. Typically, there's also a design review meeting attended by senior engineers and domain experts. In that meeting, I would be presenting my solutions, and people would ask questions and point out things to make sure all cases have been considered. This generally helps uncover issues and vet the solution works well before starting the actual implementation. This helps avoid wasting weeks or months going down an incorrect route. Implementation is the next one. This is the part where you actually start coding, and the code is broken down in chunks sent for code review. As part of that, unit tests are also required before sending the code out for review. These unit tests are automatically run for any commits that touches that part of the code in order to catch regressions. The next part is going through the cycle of QA testing, where a QA person would manually test the features and file bug reports. In this part, you'd also write a test document for the different test cases that the QA team would go through. And when the feature is ready, the last step is a gradual rollout. What this means is that the feature is enabled for a small subset of users. I would typically start with 1% of the user base. In the case of photos that has at least 1 billion users, that means enabling the feature for 10 million accounts. These are chosen at random. I would then go through the cycle of checking the metrics, analyzing the server logs for any issues, and checking out the server graphs for the system health. If everything looks good, then I'd roll it out some more, monitor the servers, and logs again before rolling out to more users. This is generally one of the reasons why when Google publicly releases a feature, it takes some time for everyone to be able to access it. Also, as part of launch planning, there are contingency plans in place and steps of how to roll it back in case there are issues. There are also typically on-call folks that the system automatically notifies for unexpected server behaviors. And then the cycle repeats for a new project. So an example of a project I worked on in Google Photos is this memory located at the top of the app. This project was about grouping your photos based on a particular topic and generating a memory for it. For instance, being in a beach or in the playground, or in the case of this example, grouping all the photos related to being in the woods. This feature is quite involved because what it is that it basically tries to find all your photos, analyze each of them, and determine what the topic is of that photo. The first part about the work involved here is the AI component around it. It tries to figure out signals from the photos that would indicate the high likelihood of it being about the woods. The signals should be smart enough to avoid false positives, such as including photos that just happen to have trees or many plants around it. Second, you would also want to exclude photos that are not visually pleasing. For instance, if they are blurry or the person in the photo is cut off. These photos, you would also want to exclude them. Another part to this is writing an algorithm that is efficient and fast, because the algorithm is analyzing each photo in an account to figure out which ones to include in the memory. So in my account, I probably have more than 10,000 photos. And you can just imagine that if there are thousands of photos in an account, multiply that with the 1 billion users that Google Photos have. That's a lot of processing time needed to be able to do this. And so you wouldn't want to take months before your feature becomes available to all your users. Hence, it becomes absolutely necessary that your code is efficient and optimal to support the user base of the product. Okay, I think I only have 3 minutes. I'll try to go through this last part quickly. So now that I've given you an idea of what it is like to work at Google and the types of project you can work on. The last topic I want to talk about is the interview process for software engineering. Most companies do the same thing. The technical interview tends to be very algorithmic and tests on computer science fundamentals. So the picture at the top tends to be what the phone interview screening looks like. Basically, the interviewer, you'll be talking on the phone with the interviewer, and there's like a shared document for you to type in your answer. They do expect you to come up with a solution, a working solution to the problem in that interview. And then the one at the bottom, the one with the whiteboard, that is what the on-site interview would look like, where basically there's an interviewer on the desk, and then you'll be drawing on the whiteboard the solution to the question. I'll skip through some of these of what I was about to say, but one thing I want to point out here is that I added some resources here for anyone who would like to, when you need to prepare for an interview, a technical interview. The book, one is a book, and one is an on-site platform, a website, so the book is Cracking the Coding Interview book. There's about 189 programming questions there. And then the website is like just many different problems that you can practice on. So we're at the end of my talk. I hope that my presentation and the stories of my experience working at Google had been enjoyable and informative. I am very grateful to be here. And thank you, everybody. If you have any questions or follow-up, if you'd like to reach me after this talk, feel free to email me at the email address that I have on the slide. Thank you.
All right, thank you so much, Ms. Charmaine Liu. All right, so later, Ms. Charmaine Liu is part of our panel discussion. So any questions related to her discussions will be answered there. All right. Okay, so before we head on over to our break, we would also like to thank our sponsors for making Y41T 2021 happening. All right, so thank you to ASUS, Paymaya, Smart PLDT, Oracle, Linux Professional Institute, Palo Alto Networks, Microgenesis Business Systems, Archer M Security, Empire Locks, Felta Multimedia Inc., Panadera de Pantoja, and Teleperformance. We also like to mention that we're looking for info system developers and web app developers. So if you would like to start your career in these positions, please send your CVs to Janine Gatchalian at jfgatchalian@up.edu.ph. Again, that's jfgatchalian@up.edu.ph. For more info, please see the details on what's shown on the screen right now. All right, so for our students naman, here is how to request for your Y41T 2021 e-certificates. All right, so please use the bit.ly link shown on your screens. An e-certificate will be provided for a fee of 100 pesos per session attended, and a total of 600 pesos if you will join all six sessions. The e-certificate will be sent via email as soon as we have verified your participation, and an e-copy of your payment receipt uploaded via request form. You can also opt to make a one-time payment via